Okay, hey everybody, this is Mr. Bells again. This is a section 4 or 5. It's working on solving polynomial equations. We're going to do them both algebraically, and we're going to do them with the use of our technology, and then get some applications at the end. So stay with me on this. I believe this is going to be good. Follow along, and here we go. We're going to start with a problem like this. Remember, you can pause the video at any time that you need to be able to write some of this stuff down. But we're going to try and solve some equations, and you know, this is a more advanced class, so we are making stuff a little bit tougher. So the first one I'm going to do is I'm going to try and solve x cubed plus 5x squared minus 14x equals 0. I'm going to try and do this one without the use of a calculator, so no technology on the first few of these ones. Okay? So one of the things I'll notice is there's an x in each one of those things, and you're like, oh, hey, I know, Mr. Bells has talked about that. I want to factor like a dentist. So I'm going to pull out an x, and then after that I'll have x squared plus 5x minus 14 equals 0. And it's at this point right now we know that if we have something times something equals 0, then that could be 0. So one of the solutions, because I had an x common, has to be 0. So I'm going to write that one over on the side, and I believe there's going to be more. And then I look at this expression which was left, and I say, hey, can I factor that? And you're like, some of my factoring is getting better because I keep practicing this. And I get x minus 7 and x plus 2. So if I try this and I multiply these, go back together, I get x times x is x squared. Like, yeah. And I get negative 7 times negative 2, that's negative 14. Yeah. And I get negative 7 plus 2, that's negative 5. Ooh. Ooh. Okay, so what I want to make sure you do is don't just assume that you do it right. Make sure you check each time, and that's why I wrote this one down like this. When we check each time by multiplying them back together, we can know I need this to be a plus 5, and this is going to get me a minus 5. So I really want these to look like this, x plus 7 and x minus 2, and that's why there's a difference between those two things. And if these are my two other factors, then I know that negative 7 is a solution and 2 is a solution. Good, so that's by factoring. This one right here, we're going to solve same way. We're going to solve this one by something called grouping. And I know it looks scary because there's all those, there's like 4 terms, 1, 2, 3, 4. There's nothing common. I can't pull anything out like a dentist. So then I go, maybe it's not as scary is what I thought. So if I see one of these 4-term things, I'm going to try this. I actually can get an x cubed by doing an x squared times an x. And the way this one's written, it kind of solves itself. So I know right here, this term's got to be a 3x squared. So I've got to have a 3 multiplying an x squared to get a 3x squared. Well, that means the 3 has to go here. That way the outside of these two things, now, when we FOIL, right, the outside will get me 3x squared. Now I look at this one, and you're like, x has to multiply what? It has to be a negative 4. So I put a negative 4 in there. So I got x squared minus 4 and x plus 3. Sweet. Now if I multiply these two things back together, I will get what I started with, so I know that that's right. And then you're like, hey, Mr. Bells, that is a difference of squares. So I know that if I have a perfect square and a minus sign, that's x plus 2 and that's x minus 2, along with my original x plus 3. And it's all of those things that multiply together to get 0. So again, either this or this or this is 0. So it means my solutions to this equation are negative 2, positive 2, and negative 3. Remember, they're always the opposites of what are in here. Because if I take a negative 3 and I plug it into this parentheses, negative 3 plus 3 is 0, and 0 times whatever that is still 0, and 0 times whatever that is still 0, and that's why the equation equals 0. Okay? So this next one looks kind of scary, looks kind of sketchy on this. I got to be careful on this one. So what I'm going to do first is this. Whenever I have an equation, if I want to use this, these something times something, something times something times something equals 0, means I got to set it equal to 0. So I'm going to rewrite this and write it as 4x to the 7th minus 36x to the fifth equals 0. Now, it looks kind of sketchy too, but maybe I can pull something out. Is my dentist available to me? So 4 goes into 4, and 4 also goes into 36. So that means I can pull a 4 out. This has 7 x's, this has 5 x's, so there's at least an x to the fifth common between these two things. So I pull out a 4x to the fifth, that's my greatest common factor, and I'm left with x squared minus 9. Yeah, it is. Okay, so this x to the fifth really means it's an x times an x times an x times an x times an x, which means my solutions could be a 0. That could be a 0, right? Because 0 to the fifth is still 0 times 4. Now, technically with this, because this is a degree 7 polynomial, technically, and I don't know that we're going to get into it that much in this class, but there's actually a 0 for each of those. So there's actually 5 solutions that are zeros, and we'll get into it in a different course, but that's just throwing that out there right now. This left over is x plus 3 and x minus 3, because that's a difference of squares, which means 3 and negative 3 are my two other solutions. Again, the 3 from this one, negative 3 from that one. And you can see now that I actually do have 7 solutions. A 0 5 different times, a 3, and a negative 3. And I have to have 7 of them because it's a degree 7 polynomial. Okay, this next one down here, this looks scary, right? X cubed plus 7x squared minus 6x equals 48 plus 3x squared. And I'm going to just show you a quick little thing. Cubic function, right? The cubic function, that's going to look something like that. Over here on this side, that's a quadratic function. It's going to look something like that. Well, that means that there's a chance that they could intersect. They could intersect one place, they could intersect 3 places, they could intersect 2. So there's different possibilities for this problem solutions just from quick little sketches, okay? But what I'm going to do is I'm going to set it equal to 0 and go from there. So my new equation should be x cubed, right? When I move this 3x squared over here and make it negative 3x squared, that should get me plus 4x squared. And then on minus 6x doesn't change. And then this 48, when I move that over here, it's going to be minus 48 equals 0. So now I got a cubic equation. So the question is, does this thing factor? Does 4 times 6 equal 48? No. So that means I can't do it like I did this one up here. In fact, this one probably doesn't factor at all, and I can't pull something common out of this. So at this point right here, we're going to skip the factoring things, and we're going to go right to our technology, and we're going to graph it. So I'm going to pull up my graphing calculator here, turn this thing on, move this up a little bit so you guys can see that, and I'm going to graph y equals x cubed plus 4x squared minus 6x minus 48. So I'm going to get rid of any of my old equations that you might have seen from some other video. And in here, I'm going to go ahead and put again one more time. So x, that's this key right here, this xt theta n. I'll move this up so you can see even better right now. The little angle up key is exponents. So I'm going to hit that. On this newer calculator, it'll raise it as an exponent. On the older, this calculator right here, it'll show that little arrow right like that. Okay. So I got x cubed, 3. Now I have to hit the side arrow so it's not in the cube spot anymore, side arrow. And I still have, plus 4x squared, so plus 4x. I can use the squared key, which is right over here, or I can do raised to the second power, whichever one. I'm going to use this one because then I only have to touch one button. And it moves it all the way down. So plus 4x squared minus 6x. Minus 48. And then I'm going to go ahead and hit graph. And zoom 6. Zoom 6. That gives me a standard viewing window. And you can see that it touches right here. So that is the solution. That's where it equals 0. But this looks just like a line, right? So I'm wondering, what is the rest of my cubic function look like, because cubic functions could do bendies and zippies and backs again. So I'm going to zoom out here for a minute and see if I can see anything else. Oh, did you see that stuff happening right down there? So I'm going to go a little bit further down. I can see that it's down on this. I don't need to go as wide. So on my window, I'm going to go my x's from -20 to 20, and my y min, I'm going to now make -80, and then hit graph. And now you can see my cubic function a little bit better. So where does that cubic function equal 0? It's obvious now it's only at that point. And we've talked about this in this class, many different ways for us to be able to find that. I think the easiest way is just to go y equals 0 in one of my other lines and hit my graph. And now you can see I want to see where the blue crosses the red. Second trace, number 5 intersection, enter, enter, enter. And it tells me that my x value is 3.0654239. So 3.0654239. Now, here's the question for you. If this is my crazy number for x, that's my only solution for this equation right over here, was this factorable? And the answer, of course, is a big ol' honkin' no. Because if it's factorable, I'm going to get nice, pretty numbers. This is not a nice, pretty number. And in terms of my stuff, I'm totally okay with 3.07. Okay? So if I have a big equation, I just want to solve it, it's always available to be able to graph it, use our technology to find out what that point is. Okay, last one that I'm going to do for you right now is this. So I have a, what is supposed to be a rectangular prism that has 3 dimensions on it. You can see that the height is x minus 3, the width is 2x plus 6, and the depth is x plus 5. And I want to know what is x if the volume of the box, so how big do I need to make x, if the volume of the box is going to be 1,000 cubic centimeters. 1,000 cubic centimeters. So let me show you this without the technology first, a couple little things, and see if this works out for you. So I believe that the rectangular prism volume formula is length times width times height, or width times length times depth, whichever way you want to do it. So I know volume equals x minus 3 times 2x plus 6 times x plus 5. And I want the volume to equal 1,000. So I'm going to write 1,000 equals x minus 3 times 2x plus 6 times x plus 5. And I'm trying to solve this. So I could do this 2 different ways. I'm going to show you 2 different ways on the calculator right now. One, here we go, turn this on and move this up like this so you don't have as bad of a glare on it for you. Yeah. Okay. I'm going to go ahead and type it into here. So I had a, let's see the problem with it again. Let's see that. I had an x minus 3, right? So parentheses x minus 3, close parentheses, parentheses 2x plus 6, close parentheses, parentheses, x plus 5, close parentheses, like that. So I've got those, and that's my volume formula. And then here I can simply put 1,000, because I want to know where these 2 things, where the one equals the other. So if I go to my Zoom 6 window, you can see that that's my cubic function. But I don't exactly see my 1,000, do I? Right? And the reason is the top of my window right now is 10. And 1,000, watch, I'm going to make my y max 100 and do this one step at a time. So there's my cubic function. So 100's right here, but remember 1,000's still way, way, way up there. So now I'm going to do my top of my y max. I'm not going to do it at 1,000 because I want to see it. So I'm going to do it 1,500. I'm going to go 500 above it, or basically half again as high. Then you can see my graph. that actually does intersect, that there is a solution right there. And how do I find that intersection point? I simply do second trace, number 5 intersection, enter, enter, enter. And that tells me in order for me to get a volume of 1,000 cubic centimeters, that my x needs to be 7.095. So let's go ahead and write that. X equals 7.095. Looks like somebody's trying to get a hold of me right now. We're going to mute that for a second. Sorry about that. And we'll go on from there. Okay, so the other way that you could do this is you could simply go here, and instead of setting it equal to 1,000, you can simply subtract the 1,000 right here, minus 1,000, and that's just like on your equation right here, moving this 1,000 to the other side, right? Subtract 1,000, subtract 1,000, and then you'd have it set equal to 0. So watch. Remember, 7.095 was our answer. So now I'm going to go ahead and do zoom 6. And you can see that my graph shows up right here. I wanted to know where it equaled 0. So I'm going to go ahead and type in y equals 0. And it intersects right there. And amazing. Watch. Second trace. Number 5 intersection. Enter, enter, enter. And you can see that the answer again is 7.095. So whichever way you want to do it to get that solution, you can do it. Now what does that actually mean? I would then take that 7.095 and I would plug it into x minus 3 to then find the height. I'd plug the 7.095 into 2x plus 6 to find the length, and I would plug it into there to find the width. And that is our applications with quadratic solving. Again, solving quadratic equations, use your calculator. Remember, if you're having issues with the graphing calculator, you can always go to that MathBits website too. That'll give you lots of good, helpful information for that. We'll practice some more of these things. You guys got any questions, you can see me during class. Thanks.